walls. We were I first met this very talented man 9 years ago at a conference on his home turf in Storrs, Connecticut, where he's professor of geology at University of Connecticut. And I loved what he said about walls, and it made me look at them very differently. And I thought he would, if he came and talked to us, it would help North Salem really get aboard for protecting and maintaining, saving all of our stone walls. I don't have too much more that I need to say about him. He's written some wonderful books, stone by stone. I'm sure he will talk about to some extent. I'm going to hawk this one too. My favorite is this little Stone Wall Secrets, which he wrote with his wife, and it's designed to interest your children and grandchildren in both geology, natural history, and stone walls. So without anything else to say, Thor,
thank you.
Please.
Thank you. That's not a stone wall up there, but it is part of the stone domain. Now what's that? It's everything that isn't fiber or wood or iron and metal that is in the historic vintage that somebody who collects old stuff might want. In order to define stone walls, taxonomically, you have to carve them out of something larger. In the same way that if you want to define a human being, you have to take it out of something larger. You know, we're primates. See? And so I've been working very hard on a decision tree, rigorous taxonomy of stone walls, and I'm not going to do that today because I've obviously got this up here. All right, but my point is that that is not a wall. A wall actually has a definition. It has 5 parts to the definition. But everybody knows what a wall is. But if you get 2 lawyers on opposite sides, it is or it isn't, it's a long pile. No, it's a short wall. You know, there's got to be a boundary point. There's got to be some rigid criteria when we begin to manage and save walls, because certainly lawyers will be involved. And there's nothing wrong with lawyers. It's just that's where the buck stops in our world, because even the Supreme Court is deciding what are the waters of the United States. In other words, you don't ask a hydrologist, you always go to the Supreme Court. And that's just the way it is. So I've been working hard on trying to vet a classification system and throw out all the bad ideas and build the good ones, and I'm right on the edge of publishing that this fall. But that's not a wall because it isn't long enough. You see? But it meets the other criteria. All right? I'll save that for later. This is, of course, what is the name of it? Balanced rock? Yeah. Not a very original name, I might add. I'm a balanced human right here on 2 legs. But the thing about me is that I have an internal vestibular system that will keep me straight up and down, right? And the rock doesn't. It has only gravity. And when I was driving by here, there was a German-speaking, chain-smoking, husky guy, you know, commenting in German about, in a very animated way about that rock. And then his partner was really, really curious, asking him about things. He was the expert, apparently. And then there was another person photographing it from every possible angle to get it. It's like, and then of course I drove from there all the way here and I didn't see a soul, right? That tells you something about the place. So I turned around. Of course you have to try and find a place to turn around, and it's not that easy on Titicus Road, but I did. And I turned around and I went back and I found myself captivated by it because it's really interesting. And I made 6 observations that were fairly quick. Number 1, there's 2 kinds of material. You probably know that. By the way, I haven't even gotten to my talk yet. This is an add-on. My thank yous go with later in the talk, so just hold those for now. Okay. 2 very different kinds of, quote, rock, i.e. material. Rock is a material, not a thing. You know, it's a material. And one is a pink granite with some dark mineral, probably biotite, amphibole, I don't know what it is, but it's a really, really nice pink granite that's got an interesting stain. It's a lot harder than the stuff that it's sitting on. The stuff that it's sitting on is, you might call it a granite, you might not, but it's certainly like that. But it's much more sheared, and it's got bigger crystals in it, and it's softer, and it's not nearly as resistant. And that's what's forming these pedestal pieces underneath of it. That's actually bedrock. Those aren't stones that just happen to end up there. It's actually bedrock. So the stone is the balanced rock, and the rock is the thing under the rock. okay, which is actually bedrock in place. However, it's fallen apart to the point where it can still support the rock overhead, but it is not exactly where it was. So those are two observations. Another two observations I would make is that there are, let's just call them beveled surfaces. If you've ever crawled around and looked at it, over here, this is a sketch map that I made. The big dark surfaces there, and there, these are actually beveled off in a plane, like you did sandpaper or something. And that's either one of two things. It's either contact, degradation and dissolution of the rock during weathering, because you'll get a clingy wet spot there where they're in contact with each other. And the third, but it could also be friction. Where the big stone is just sliding over the other ones and actually, grinding them down into a beveled surface. And I think that's what's happening, but don't quote me. Oh, rats, you got that thing going, right? Yeah, okay, so I am merely speculating. All right? But the interesting thing is that the places where the rock is really supported in the extreme aren't beveled. They're just touching. And there doesn't seem to be a lot of chemical differentiation where the oh, by the way, yes, the under rock are beveled flat, but the one above it, there's not a scratch mark on it. I can't imagine human beings working that big rock into place without denting or scratching or modifying or smearing or grinding, the overlying rock, at least a little bit. So I think it just ended up there. The third thing is another dichotomy, a set of observations. The first two kinds of rock, two kinds of bevels. All right, there's two environments that are there. The one environment is under the toadstool. It's going to be moister and darker and more chemically reactive than stuff on the outside that's going to be warmer and drier and sunnier, you see? And so you're going to get a different chemistry on the outside and on the inside. And I think that has something to do with the interesting contact between the under rock and the overlying large stone, called a boulder. That's a boulder. A boulder is a large rounded rock. Okay, and it comes from Boulderstein. It's out of the Norse. It's for thunderstone, because when they're rounded you could rock them a little bit and make noises out of them. I'm not getting very fast here. The other observation I make is that I think that when settlement happened here, or early on, that the balanced rock was actually sitting on soil. And I think that the rotten rock underneath and or whatever glacial material was there was washed out, possibly when they put the road in. Possibly. Because you would have more runoff from that road than you would not having it. And that's just speculation, a 15-minute visit, 10-minute visit to Balanced Rock, and here I am already behind schedule. Does anybody have any questions about Balanced Rock? Okay. Now, you're going to run the slideshow for me, right? Next one. Thank you for coming. Yes. It's a pleasure to be here, and thank you for the very nice introduction. Yes, I'm actually invited to speak about a book that is 17 years old. That's pretty good. That's pretty good. And you know what I did? I haven't been talking about the book for a long time. I've just been talking about the subject, but I'm actually going to talk about the book today because they asked me to talk about the book. So here we are. Next slide. Well, I've chopped off the bottom of it, but that's my thank you slide. That's okay. Thank you for the invite, and this is an American Impressionist painting of the stone. I'd like to make a comment. It's from the Griswold Library in Old Lyme, Connecticut. I'd just like to make the point that the Impressionists loved stone walls. They just painted them where they weren't even there. They painted them into the scenes, all right? And the previous art group, the Hudson River School, a long ways previous, they painted them out of the scenes. So what the artists will reveal to us is what they really care about. And the Hudson River School were mostly interested in, the sublime and the magnificence of nature and da-da-da, and put a little human figure in the background somewhere, but they don't want to feature architecture, you see? But certainly the Impressionists did, a rocky, rough architecture. Next slide. Okay, so I have an outline for a very long talk, and I may skip right through part of it, because I've already spent 10 minutes on Balanced Rock. But what you've got there, that red thing, is actually a painted rock surface, but the paint was natural. Okay, that is a mineral we call jasper. And jasper is like milky quartz, but it is red. It's red because of iron oxidation, and it's just simply the red version of cryptocrystalline quartz. And that is a hydrothermal fracture. You know, so, you know, acidic fluids are circulating, you know, watery fluids and steam and water are circulating through the lava flows that were covering central Connecticut. That's at the Hillstead Museum in Farmington. And I just was walking by and saw that thing, and that's a really nice picture. And the reason it's here is I want you to think that there might be that much interest and that much beauty in any single stone out there. Yeah, I love the patina, you know, the mossy, lichen-covered, you know, sort of interesting old look on these stones. I mean, who doesn't like that? But inside those stones, there could be all kinds of interesting clues and beautiful things to observe and feel good about. So that's what that stone is. It's on a piece of lava, hardened lava called basalt. And it's a natural paint. So I'm going to use it in my spacer slide. When you see it, it means we're going to the next segment of the talk. And the segments are listed over here. I got like one slide on the author. I have one slide on something called LiDAR, or a few. And then we'll do a slide or two on poetics. I might just go fast through at that point, I don't know. But I certainly want to end with a coda on kids and walls, because we absolutely are going to send, you know, our future, you know, to kids. To kids. I became a grandpa this last year, and I've been thinking a lot more about it. I've been more flagrantly hawking the book Stone by Stone. I didn't bring enough, I mean the Stonewall Secrets, I didn't bring enough copies. But if I forget, the Smithsonian Institution said that's a notable book of the year for children when it was published, and then we forgot about it. And it won the Boston Book Builder Award for the best physically produced book. And I had nothing to do with either of that second one, you know, because it's really the materials. That's pretty much it. Then I'm going to go through the chapters in Stone by Stone with a quote from each. And I hope I make it. Let's get going. Next. See? You're going to get the spacer slide, because now you know. Truth in advertising. Next one. Okay, this is the advertisement. So I'm going to talk about Stone by Stone. I've gone places and given talks that were the wrong talks. Okay, so I need to double check the websites to make sure. Let's go on. This is Simon Shawmut. You know who he is? Author. Unbelievably brilliant passage. This is a magnificent book about landscape history and architecture and art through time and civilization. And mostly it's about, you know, big architecture and buildings and things like that. But he ends this book on page 577 with an homage to stone walls and to Henry David Thoreau, who I just wrote 3 books about, all right? Because he's really the start, to my mind, of the aesthetically driven American environmental movement. You know, who cares about stuff instead of wrecking it. He said, thank God, you know, they can't cut down the sky or they'd wreck that too. He was writing at the peak of deforestation, you know, in roughly 1860. And of course, we can alter the sky now. So here's what Simon has to say. And we are in the place that he is describing. He lives in, I forget the name of the town, but it's right off the Hudson, you know, just north of New York City. For that matter, there are places even within the boundaries of modern metropolitan sprawl. That's where we are. I call it ruburbia, a contraction of rural and suburban. You know, you don't want to be suburban, but you don't want to be rural either, or you're like 4 hours from the nearest library, you know, or medical center. So it's ruburbia. I noticed that when I moved here from Alaska in 1984. This is not rural. But it's really lovely. It might be lovelier than rural because of the texture of the landscape. Modern metropolitan sprawl, there are places, blah, 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 where the boundaries between past and present, wild and domestic, collapse altogether. Below the hilltop clearing where my house stands are dry stone walls, the remains of a vanished world of sheep farming and dairying, made destitute a century ago. The walls now trail across a densely packed forest floor hidden from view by the second growth canopy of tulip trees, white ash, and chestnut leaf oak. From the midst of this suburban wilderness, in the hours before dawn, barely a fair way away from the inevitably manicured country club, coyotes howl at the moon, setting off a frantic shrieking from the flocks of wild turkey hidden in the covers. This is Thoreau's kind of suburb. Now, I'd call it reverbia, but you know what I mean. He's writing about the place we live in, that our landscapes and our memories are tied together. They are impossible to separate, to my mind at least, because what interests me about the stone walls is not so much the modern architecture or the latest thing. They are ruins, they are artifacts, they are archaeology, they are tied to history. Next one. That was easy. One slide. I'm the one on the left. And I'm the only one with my pants down, but I decided not to show it. And it's me, I'm the only one not focused on what I'm doing. Okay? And those are my two brothers. And I was raised in a pack of 5 children under 5 years old. And I tell you, individuation was not the thing. You know, it's like everybody was the same. It's like a platoon of soldiers. Everybody is the same, you know, at least in the way of you're supposed to behave and do. So I just saw that the other day and I decided to introduce myself. Orion Magazine asked me to write a very short bio, you know, byline, when I did a book review last summer. And it's a literary magazine. And I said, Midwestern native turned Western geologist. I was not a professor, I was a real geologist for a while. Turned Eastern professor. So that's 6 words, that's me. And I've always been a little bit odd. This book doesn't really count much in my business. It's the blind double peer-reviewed journal article is what the coin of the realm where I work. Next slide. That was easy. LiDAR. LiDAR is, go ahead. LiDAR is light imaging and ranging. Let's get the next slide. Okay, light imaging and ranging. How many of you have seen LiDAR before or used it? Okay, just a couple. Okay, let me explain what it is. When you are flying in an airplane and you look down on the landscape like this, even during the summer, what's happening is there's a lot of rays reflected right back to your eyes, and you're seeing like billions of rays coming into your eyes. And yet some of the rays are from the forest floor, but they're drowned out by all the ones on the tree canopy, you see? In other words, you see mostly trees. When you look down in the white box, you see mostly trees. Your eyes can't subtract out all the green, all the leaves, but you can program a computer, right, you can send laser down to the ground surface, right, and then have it bounce back. 99% of those rays are going to hit a leaf or a twig or something like that, and they'll be scattered off in different directions. And you will see the leaf or the twig or whatever. But if you're a computer and you can rule that out, you can subtract out every possible ray except the lowest. And then you can take 1 in a million rays come back, and then you can sort of generalize them over the area to sort of reconstruct the topography. And you can see things at a meter scale below the canopy of the trees that have grown back that have made these walls archaeology. So what we're going to do is look at this box in white, and especially that little cell there. That's the only pasture left open. This is right around my backyard. I mean, this is your backyard. This is wherever you don't have, you know, houses or anything. It's woodland. It's all regrown. Let's look at the next slide. There it is on the right. Inside that box are stone walls everywhere. Now let's go backwards one. You see? It's mostly forest, but you can see the different kinds of forest here, right? You can't even see the walls around here because the trees, of course, have shaded them. But they're there. There are walls everywhere. Back again. The colors are topography. It's high on the left and low on the right. You can kind of ignore that. But we're basically going down a hillside. And look at all the walls there. So we are now using LiDAR to map and uncover and discover stone walls. Every town, every land trust, every sanctuary is starting to map their walls more effectively. So what I'm trying to do is develop, and New Hampshire is mapping them, for God's sakes. New Hampshire, the State Geological Survey is mapping these. So they are landforms. They are habitats. So we're beginning to map them, and I'm very involved in the classification of them because, of course, form and function go together. But I wanted to show you what LiDAR is. Next slide. Okay, now this is Block Island, and right there is the end of the pier, and right there is the tallest hotel, right there. Can you see that barely? Good, even in the back of the room. I took this picture probably in the 2007 or 8, something like that, from Beacon Hill. From the exact same place the next picture was taken from. Let's look at the next one. This is the end of the pier, right there, and that's the tallest hotel, right there. So the focal length of my camera is different. The imaging is a little bit different, but I am looking at the same place. And what happened? The trees came back. You see? If we had all the trees gone, it would look like that. Now, some of them are gone, but most of them are still there. If you can't see them, let's toggle that back and forth once. This is the kind of landscape we live in, but we can't see. And LiDAR is helping us to see them, because we get an accurate map view from the sky that we can do something with instead of an oblique artistic view. Next slide. Poetics. Mary Oliver died last year. She wrote an amazing poem about stone walls. Let's see if I can find it. It's in my copy of Simon Schama. If I remember, I did it right. Yes, I did remember to print it. It was called Knife. We know the most famous poem about stone walls, Robert Frost. It's on the desk when I walked in here. It's called Mending Wall. Something there is that doesn't love a wall, blah, blah, blah. Oh yeah, but this is the one. Thank you, my helpers. So, Mary Oliver is writing a poem called Knife, and there is no actual knife. It's a metaphorical knife. And the whole point is the contrast between what the walls give us relative to the craziness of our lives. Something just now moved through my heart like the thinnest of blades, as that red-tailed hawk once with its great wings and flew away above the gray, cracked rock wall. It wasn't the bird, it was something about the way the stone stays put, whatever goes flashing by. Sometimes when I sit like this quiet, all the dreams of my blood and all outrageous divisions of time seem ready to leave, to slide right out of me. Then I imagine I would never move. That's the key. You're the wall. I would never move. By now the hawk has flown 5 miles at least, dazzling whoever else has happened to look up. I was dazzled, but it wasn't the knife. It was the sheer, dense wall of blind stone, without a pinch of hope or a single unfulfilled desire, sponging up and reflecting so brilliantly as it has for centuries the sun's fire. End of poem. Just an amazing set of words to me, that someone would imagine a wall that put, that solid, that stable, and it is relative to our lives. But I like to use this poem as a counterpoint, that if you think geologically, if you think at the millennial scale, or you think at the multi-millennial scale, or you think in a series of geological epochs, that stone is transient, it is moving, it is falling apart. It is disintegrating at a scale that gives me a calendar that I can use to help clock the passage of time. I don't know about you, but I get calendar time, you know, and I get clock time, and I'm really used to it. And I can even get century time. And then I could get geological time because it's another abstraction. I can think in millions of years if you practice long enough. I get it. It makes sense. There's no pretense that I can really understand it. I can only intellectually understand it. But the stone walls help fill that gap in at the millennial scale for me. And so they really are helpful. Next slide. Next slide. On the left is a wall I built out of dead wristwatches and stones. And on the right is the mending wall in Derry, New Hampshire, where Robert Frost wrote that poem. That poem isn't about a wall, it's about two walls. He wrote it when in England, and he got two of them mixed up. The one that has balls and lobes, you know, and falls apart. The other one's fairly stable and flat. Good fences make good neighbors. And he conflated the ideas between the two of them. Next slide. We're moving rapidly along here. That's good. Now that is not balanced rock. That's wolf rock. It's just in my town. You've got them around here. It's the same basic idea. It's a rounded, imported, glacial erratic that comes from somewhere else. And erratic is not every big stone. It's anything that's out of place. It comes from the Latin errare, which means to wander. It's not in its place. Usually because it's too big. But sometimes composition or markings. At any rate, that's a nice erratic, but it's sitting on rock. Solid rock. Your balanced rock is sitting on fairly rotten rock. Next slide. Stone is the material. Whoops, I just blew that. Rock is the material. Blew it. Rock is the material. Stone is the object. If I hold this up, right, and I give it to you, you say thanks for the chair because you're interested in the object. But if you were freezing to death in front of a fireplace and I gave it to you, you would say, thank you for the wood. Grave rock doesn't make any sense. Gravestone does. Gemstone makes sense. Gem rock doesn't. So you go into a rock quarry and you take stone out. Rock is the material, stone is the object. Did I get that right? Yes. Okay. Yet you will hear all kinds of things. You'll hear about rock walls, but they're mostly stone walls around here in New England because the more useful it is, the more likely you are to use the word stone. The more special, the more derived, the more beautiful, the more unusual, the more likely you are to use the word stone. The thing on the upper right, we'd never call that a rock because it's special even though it's just as rocky as the one down below. It's made of slate instead of granite, but they're both perfectly good rocks. Next slide. This is my favorite. The bottom of every slide is chopped off just a little bit, don't worry about it. This is Block Island, Rhode Island. I'm sure some of you have been there. This is the biggest mix-up I've ever seen in New England. They can't figure out whether it's a rock or a stone. Because they call it Settler's Rock, but then on the plaque they say this stone was placed here. So it can be both at once in their minds to the point where they don't even know the difference when they set this in there. Next slide. Wall versus fence. The thing on the lower right is a perfectly good fence. Most of the fences in the world are really probably animal territories. You know, scent fences, animal markers, territorial markers. Those are fences when they're just markers. It's to keep something out to go in. It's the same as offense, defense, or to fence, as in with a foil. You know, that word, that's about keeping something in or keeping something out. It's a function. And wall is an object. Wall is an architectural thing. It's real, you can touch it, unless you're being metaphorical. It supports or divides. We've got them on this building here. And you've got them out in the fields. They can be freestanding, in which case they divide, or they can be connected to something above it, in which case they support. Often they do both. The interior walls of a house divide and support. So there's a difference. Next slide. To make a wall, you've got to have 5 things. A stone wall. It's crazy to think that something you already know very well, your brain is so smart, it like puts all of those things together and you don't even think about it. But there are 5 things that go together when you say, oh, that's a stone wall. And I saw gorgeous stone walls coming down here from the Interstate 84. Number 1, a stone wall is made of stones, meaning it's granular, meaning it's made of little things, you know, that are put together to make a bigger thing. You take the stones and you put them together and you make a wall. They're like pieces, just like a beach is made of pieces. You see? It's made of pieces of sand. So a wall is made of pieces or stone, so it's granular. A wall is elongated. You wouldn't take a cairn or a pile and call it a wall if it's just round. You'd call it a pile or a cairn, you see? So a wall has to be elongated. And by my judgment and by other judgments, empirically, the ratio is about 4 to 1. It doesn't matter whether it's exact, it's that you agree on a length-width ratio. So a wall has to be elongated. It has to be continuous. This is not a wall right here. We've seen these all over the place. But if you pushed them together, they'd be a perfectly good wall. You see? It would be granular. It would be elongated. So that's what I call a stone line. And there's many kinds of those. There has to be a height requirement. A wall has to be high enough to be significant. And 2 ways of doing that. One is if stone is resting on stone, I'm calling it a wall. Because maybe it was higher at one point, and there's so many things that we call walls that aren't necessarily built up in a really beautifully well-laid structure. They still qualify to be called as walls. But these are too low. So this meets all of the criteria of a wall, but it's too low. If they're merely abutted together, okay, then knee-high. Again, I need an arbitrary, but it doesn't matter what it is. You know what I'm talking about. The things you'd likely to call a wall are probably at least ankle-high. Next slide. This is what I mean. And these are the ones that I really go for. I love roadside walls, of course. I love garden walls, patio walls. I love them all. You know, but the ones that I wrote a book about were the artifacts, the ruins, the ancient stuff. And you can still be using ancient stuff. It works. Stradivarius violin is beautiful in 2 ways. Next slide. By eye candy, I mean no words, just pretty pictures, different kinds of walls, so they make sure you know that all walls don't look alike. And some I like better than others, but in fairness, I'm showing you a variety. I have an ugliest wall in New England, but I'm not showing it. Next slide. Because it borders on nature pornography, to my mind. I'm not going to show it. Next. Okay, the 4th to the last one was on Asylum Avenue in Hartford. Asylum, you know that orange one? Yeah. Okay, close call. If we like, let's make the assumption we like stone walls, that her interest is conserving and preserving them and making them be important to our history. We damn near lost most of them. Next slide. Oliver Bowles would have taken most of them down. Now I want you to go back to the 1930s. The Model T didn't become affordable for most people until the late teens. You know, it came out in 1914. Oh, that's cool. I can't afford it. 2 years later, oh, that's cool. The price has dropped. I can afford it. So we're looking at the late teens when we began to see cars, you know, with just normal people driving cars instead of a real special deal. And New England roads were terrible. Okay? They were so bad you could hardly get a horse on them. It was dangerous, you know, walking, whatever. But for cars, they really needed to be upgraded. And you know how bureaucracies are. It took a while for them to get organized and say, we demand better roads, you know, and elect politicians that will, instead of arguing about tolls, you know, they'll argue about better roads. And so we began a road building program, and Oliver Bowles was a mining engineer. And he said, whoa, look at all the potential crushed rock we have, you know, right within reach of all of our roads, right here in New Salem, okay? Why don't we just improve our roads by crushing all of those stone walls and spreading them out? And he was partly successful. We lost a lot of stone walls that way. And some of the main, you know, the main turnpike is underlain by crushed stone walls. They just want aggregate, you know, like coarse stone, affordable and cheap. And it became real cheap when this, see that wall out there on the right? He would have taken that thing and turned it into road, because road is more important than beauty. Its function always takes precedent. Not to me, but to democracy it does. The next slide. That's the rock crusher from Stamford, Connecticut, not that far from here. You could feed a stone wall in that thing and probably take out hundreds of feet of it a day. Easily. And you just crush the stone and it goes out and it lays down a nice flat gravel roadbed. What do we do now? We go to the black trap rock ridges and we crush that basalt, we quarry it and then we crush it, and that's what we use for a lot of good roadbed. We need that stuff. Well, they were making that out of stone walls. There was a property, and New York Times covered it, and then I ended up writing a column, an invited opinion piece, and they titled it Strip Mining History. Because they went to Lisbon, Connecticut, and took 26-acre property and stripped every stone wall off of it, right? And put it on flatbeds and shipped it out west because you can make more money doing it that way. I don't know where it went. The saddest case I know of was a town near me where the developer went into like a 20-acre property and took all the stone walls off, built tract housing, you know what they look like, cookie cutter McMansions kind of thing all over the place. And then what he said was, hey, how'd you like a stone wall to go around your new house, right? And then charge them triple to put it back. You know, things like that have been happening. And I was propositioned 3 times, you know, to sell walls around my puny little 5-acre property or something like that with you know, like a 50s ranch on it, you know, but you know, still it had 4.8 acres, and there's no way I would sell my stone walls, but I got solicited. We want to buy your walls because we can sell them. We'll give you a good price for them. And that's where Stonewall Secrets got started. You know, the first page, we'll see it later, you know, the owner is the grandpa, you know, and his kid says, hey, we could use the money, you know, but he's reading the letter from the stonemason that says, we want to buy your walls. Will you sell them to us? Next slide. This is even crazier. This is in the White Mountains National Forest up north of here in New Hampshire. They took the walls and simply laid them onto the ground and then put road above them. That's crazy. Well, it wasn't crazy. It was perfectly logical when roads are a priority over aesthetic beauty and historic heritage. Next slide. There's so much information that would be lost if we took all the walls away. Because every once in a while, as in indexed in yellow here, you will see, you know, some mention of stone walling in historic documents, but it is so rare. It's so rare that only maybe 1 out of 1,000 walls is documented. And even if they are, well, not documented, what I mean is, why do they look the way they do? Why are they as high as they are? Why are they wide? Why are they put together the way they are with these materials? That's what I mean. All you do is getting stone, building wall. That's about as specific as it gets. And this is rare. Usually you have nothing, except maybe a mention in a deed. So if you were to take these stone walls away, we would lose the archaeology. Next slide. And so this is a play on a book that I loved. It was by James Dietz on the left. Historic archaeology was essentially invented about excavation. It's about the small things forgotten and fallen below the soil, like buckles and bullets and musket balls and broken pieces of porcelain and clay pipes and arrowheads or whatever. They're small things forgotten. That was a gorgeous book. So American historical archaeology obsessed with excavation of small things forgotten. That's okay. And in the background in New England, are these large things overlooked? The stone walls. Yes, archaeologists noticed them and they mentioned them, but you know what? If you were to find an arrowhead on one of our stone walls, you'd have to stop and do some kind of a cultural management thing, you know, for the potential archaeological site, but you could strip away all of the stone wall because it's not being thought of as an artifact. It hasn't really entered that. Now, of course, things are changing. They're more and more preserved. We're making progress. But I've been a stump evangelist for stonewall conservation, you know, since the late 90s. And I really am seeing some progress. And a lot of people are working on this. You know, you're working on it. You're working on it. You know, but it was a close call, I think. So I really think we can use old walls to reconstruct a lot of early historic life that is not in our documentary evidence. Next slide. Purpose. Next. That's my purpose. This is one of the saddest scenes I've seen. It's on the left. A lot of stone, 20 years ago, lots of this was visible. I got stalled once heading west on Hartford, you know, and there was an 18-wheeler next to me and it had about, you know, 20 of those pallets. The lichens and the moss are just clinging on them and the soil isn't even washed off yet. They've just been strip mined. And on the right is a strip mine one. I used to drive to the beach down to Rhode Island from Storrs, Connecticut. It was pretty easy to get there. Very normal route, hour and 15 minutes down there. And one day I went and 3 of these walls were gone. They were just simply lifted up. That's a roadside wall. Next slide. All of that is prelude, okay? Preface. Stuff I wanted to mention and get through before I did stone by stone, which is my task today. So now I'm going to go to a very beaten up copy of this book and go for it. And it'll be mostly readings. And you can hear me in the back there? Okay, let's go for it. These are the chapters. It's a narrative. The introduction, it basically says what you're going to read. But once you get past that, we're starting with settlement in the early 17th century. New England and Old England. That's the attraction. That's the get to notice. But then it's narrative. You got to make the stone. Then you got to bury it. 17,000 years worth of forest processes are burying the stone. Then you take the forest, because that's what we did. We took the forest in order to put good agriculture there. I got no problem with that. And when we did, there was a lot of stone show up. And a lot of it is an artifact of our, or an impact of our land use practices. In other words, we made a lot of that surface stone. Not all of it, there were patches everywhere that were stony. But a lot of the stone came up as a consequence of taking the forest away. And of course, we build walls out of it. Why not? Land abandoned. As you know, people walked away from these forests. Property in New Salem was very, very cheap at some point. In the 1890s or the 1910s, the price came back up again. There was an interval of neglect. People walked away not because the soils were so bad, but because American culture changed. Rural revival, beginning with Roosevelt around 1905. They wanted to repopulate an emptied New England. There's that old saying that if America had been settled from California side and worked east, that all of New England would be one big national park. It just happened to be settled in the wrong side. And then the last 2 chapters are somewhat reflective. You know, back to nature, the so-called environmental movement, and then written stone, what do we make from it? So those are the chapters. I'm going to try and do a reading from each one and make it through. Let's move on. Oh, and that's just a picture from Stonewall Secrets on the right, just to keep your eyes mellowed. Introduction. No, go back one. There you go. And those are page numbers for me. There are old stone walls elsewhere. Page 1. But only in New England do they rise above the level of architectural ornaments to the status of landforms. Kentucky has its caves. Florida has its coral reefs. That makes sense, right? Yeah. Louisiana, its bayous. Arizona, its canyons. Washington, its volcanoes. Minnesota, its lakes. And New England, its stone walls. The landscape would simply not be the same without them. They are our signature landform. The New Englanders went all the way to Minneapolis when they settled. Right across upstate New York, right across into Ohio. They just kept going. You find congregational churches and town greens and sugar maples along that whole stretch. But the stone walls drop out at the Hudson River, just on the other side of it. They couldn't be brought with them, okay? So they define our region. If you go from Fairfield, Connecticut, or where we are now, to the other side of the Big Apple, down into central and southern New Jersey, you lose the walls. You lose them for a different reason. You lose them because we don't have glacier bottom soils. If you go from southern Maine to northwestern Maine, you lose them. You've got hard rocks, okay? You've got glacier bottom soils, but what you're missing is the livestock tillage agricultural practices that gave us the walls. So you lose walls to the west because the rocks go soft. You lose walls to the south because you lose the glacial soils. You lose walls to the north because you run out of livestock tillage agriculture. And only in New England do all three of those pieces come together regionally, to the extent that the thing about New England is explaining the absence of walls. Even though there are walls in every other state, but when you find them, you have to explain them. You don't have to explain them here. They're just part of the tapestry of the landscape. Next slide. Indeed, the English felt right at home, naming their communities Cambridge, Dartmouth, Ipswich, Dorchester, after similar places on the other side of the Atlantic. In fact, England and New England had similar local landscapes and climates because both lands had similar geologic history. Millions of years ago, in the Paleozoic era, Old World and New World, motherland and daughterland were formed within the same mountain range near the center of an ancient continent called Pangaea. Ever since then, these two worlds have been tied to the same geologic fate. Next slide. There's that ancient mountain range from Georgia all the way up on the other side of Norway and Greenland. Okay? The same belt of rocks in England and New England, especially in Scotland and to the north. In fact, the Appalachian Trail does not stop at Mount Katahdin, or it does, but there's an international Appalachian Trail that travels now all the way up to Norway, all right, and even in Morocco and England, trying to reconstruct the Appalachians, which were once all together. The mountains in Morocco and Norway and Spain and Scotland and England and Greenland and Norway were all part of one seam. And that seam gave us the rocks that our stone walls are made of, and they look the same over there. They're made in the same mountain route. Next slide. New England bedrock rose upward and ruptured into billions of straight-edged fragments as a consequence of what we call exhumation. We don't take bodies out of the graves, all right? What happens is the old mountain route that was 20 miles down there or 15 miles down there where we make these hard rocks, we've stripped away so much material from the surface through erosion over the years that that mountain route is now at the surface, even if it formed many, many miles down below. You couldn't get granites and gneisses and schists and hard crystalline rocks forming at the Earth's surface. They need to be down in the crust of the Earth many miles in order to form. We simply have them at the surface now because we've stripped away everything. If you had an iceberg floating in the sea and you chainsawed the top of it off, right, it would rise back up again. The same thing happens with mountain roots. Take the top 100 meters off, right, and 30 meters come back up, or 70. Not quite that much, because it's all about density ratios. I don't need to get into this, but I just wanted to say that we made the stone. And then when you get, let's just carry on. Next slide. Oh, chopped off. Okay, I feel very comfortable in Westchester County because it's in New England to me. Okay? I moved from Alaska to New England. And my parents live in Michigan, and Minnesota, excuse me. We always travel through Michigan. So I have to cross upstate New York. So, you know, pack the kids in the car and drive back and forth like 50 times. You know, I've seen a lot of upstate New York. I've seen a lot of New England. My wife's from Maine. So I got pretty used to the region. And the topography is on the left. If you see this Mount New England, that's the coherent mountain route that we're looking at. It's coherent. Look at the Hudson Valley. Look at the, you know, Lake George lowland. Look at the Lake Champlain lowland. Look at the St. Lawrence lowland. Look at the St. John's lowland up there above Montreal. You know, it's basically one coherent region. So I'm a geologist. I moved from Alaska. I'm raised in Minnesota. I show up here. I can't see the states the same way that my counterparts and in-laws do. Oh, we're from Rhode Island. We're not from Connecticut. You know, or I'm from Massachusetts, not from Rhode Island. And it just goes on and on. And yes, they're different places. Culturally, they're quite different. But to a geologist moving from Alaska, it all looks like one place. And you know, if Nantucket is part of New England and Martha's Vineyard and Block Island, then so is Long Island. It's made of exactly the same stuff, right? It's all recycled Connecticut anyway, and New Hampshire. That's what Long Island is made of. Staten Island, I'd throw in the mix too, you know, because it's identical, you know, to the other stuff. That's New England. And so the fact that this piece right here, where I am, ended up, you know, in New York State as opposed to Connecticut is pretty arbitrary to me. And this, of course, is the metamorphic grade, meaning how hard, how deep, how hot, how crystalline the rocks are. Red being the maximum. And look at that. That's the mountain route. The rocks get softer in both directions, and it just rotates up to the northeast and turns the corner into one giant mountain route, orocline is what we call it, that leans into the Gulf of Maine. Now, I know that you have more allegiance to New York City from here, but I'm just being physiographic because your walls are physiographic. Maybe your hearts and souls and minds are in New York City, but your walls and your landscape and your glacial deposits are all New England. Next slide. This is the ice recession chronology from a complicated set of dates. So the question is, when did the ice sheet disappear from here? Isn't this where we are right there? A little bit lower. Okay, so we're basically 18,000 years ago. So we've had no ice for 18,000 years, and we've had human settlement here, i.e. Euro settlement, right, in the last 400 years. So for 95% of that post-glacial time, we've been making soils and burying stones. Only exposed in the last 300 or 400. Next slide. As the ice sheet withdrew to the north, it left in its wake a lifeless, rocky, rubbly, windswept landscape. Nothing except a few bacteria had been able to grow beneath the glacier. Boulders and rock fragments lay everywhere, especially on the uplands. Soil was absent. The land had been stripped down to its essence. The landscape was all grays and browns except for countless ponds and lakes which turned blue under sunny skies as the silt within them settled to the bottom. 15,000 years later, make it 18,000, most of the ponds had been filled and turned into marshes and swamps. Only the deepest and cleanest, largest ponds and lakes remained. A thick, black, luxurious organic soil had developed over nearly everything else, burying most of the glacially scattered stones in the uplands and mulching the sandy soils of the alluvial and coastal lowlands. These soils, when prepared for seed or mowed for hay, would become the most important and indispensable natural resource in North America. Next slide. There you have it. An ant on the left could easily bury a coin or gravel because they bring material up and just dump it. They care about the chambers underground, not the anthill that they're making. They're not making the hill, it's making itself, okay? Just as the particles they dump, roll around the hole. And look at this, that pasture, that stone, that's in a pasture that was down to bare rubble in the 1930s, and we've already covered it nicely in the upper right. This is a soil just developing above a very, very thick, broken, hard bedrock. All right? And that's a steady state thickness of material on a steep slope. It's thicker on a more gentle slope. All that stone is not visible. Next slide. Intensive use. Clearly these were occupied indigenously. The Hudson River was a spectacular place. So were the rivers and wetlands. But the upland landscapes, they were hunted in, they were walked across, the wetlands, shorelines were used, things were trapped, but there wasn't intensive land use on the uplands. The vast pattern of stone walls is Euro settlement. Were there Druids? Were there Vikings? I'm not going to get into that, but there's no good evidence for it. There's suggestive evidence in places, but the burden of proof is on the more unusual claims. That is, if 1% of your phenomenon, looks weird, all right, what you try to do using Occam's razor is to include it in the 99% rather than make a new category, even if a new category is justified. I'm being theoretical here. On the right, that's the degree of settlement now, a science paper published in 2011 from a very, very extensive archaeological review. The red circle is New England, and it's been settled between 1,000 and 2,000 years ago for intensive land use. It was mostly walked across before then. Yes, we have archaeological sites, but they're encampments. Next slide. That's the Viking settlement on northern Greenland in the upper left. Those stone walls are real. They are Euro stone walls, Euro settlement stone walls, and they predate anything here by 6 centuries. But the Vikings got beaten back by climate change, right? It cooled, and they never finished their settlement plan. I sometimes wish they had. I'm a Thorson, for sure. I'm an Anderson, the other half, and the Andersons are mostly Rudneys, and the Thorsons are also Ericssons. And there's Johnsons and Olafsons, and it's just like, the family tree just reads like an Icelandic book. That's America's Stonehenge, claiming Druid remains here. That's an old quarry, but it's also a good moneymaker. It's like your mystery rock. Make an outrageous, interesting conspiracy theory about it, and next thing you know, there's thousands of people wanting to see it. Where is it? And they will never be turned back by evidence. Because it's more fun, right? And people need fun things to think about. I'm not making fun of them. I have my own peculiar conspiracy theories, but I won't share them with you. Next slide. Okay, now this is really cool to me, is that the first New England intentional permanent English settlement was in Maine. It was not in Plymouth Rock. It was not in Boston. It was in 1607. There were 2 Virginia settlements. One went to what we now know as Virginia, at Jamestown, and they barely survived. Barely. Okay? Another one went to the mouth of the Kennebec River in Maine for a second Virginia settlement under the reign of Virginia. And you know what? It was the Popham colony, and they only lasted 1 year. Here's 1607 etched in the granite under George Popham. The reason they only lasted a year is because he inherited land back in England. He said, hey, I don't care if I'm the leader, I'm going back. All right? So, but if that had not happened, New England might have been settled in a southerly direction from Maine. I mean, New York was always tied to the Dutch and the Hudson, so that's a slightly different story. But Boston, you know how Massachusetts owned Maine until it broke off? It could have been exactly the opposite. It should have been, except for the vicissitudes of circumstance. Next slide. The effect of native hostilities on New England stone walls. You know what I'm talking about. King Philip's War in the late 18th century, late 17th century. And then, of course, the French and Indian War, you know, right up through 1763. I mean, it was kind of dangerous ground in New England until locally after 1678, I believe, was the end of Metacomet's War or King Philip's War. And then 1763 was the Treaty of Paris that sort of, the French and Indian War is done, you know, so they weren't pitting the natives against each other and raiding settlements. So most settlements really are post French and Indian War is what it's called, or the 12 Years' War, 1763. Not the oldest ones, they're very old. But the effect of native hostilities on New England stone walls was to promote slow expansion of the original colonial settlements. You know, places like Greenwich and Guilford and Manhattan. You know, people hunkered down and stayed in those coastal communities for a century until those hostilities were over. Original colonial settlements around their edges rather than founding new separate colonies, especially in the deep interior far from the coast. Settlers who might otherwise have struck out to create new colonies in the wilderness instead remained in existing villages, crowded with their relatives, waiting for things to change. The delay caused by Indian hostilities coincided with and reinforced the delay caused by the lingering attractiveness of the river interval lands and their productive alluvial soils. Only after supremacy over the natives and the British became assured, and only after the interval lands became full, would there be a burst of settlement into the wilderness. And it was a burst. Next. That is a hillside, probably in the Berkshires, getting a haircut. I haven't been able to source that. But think of the taking of the forest as like a guy with a stubble beard, you know, just taking it off. Half of the face, and then going to work with half of it shaved and the other half not. That's kind of the image you get there. When you take that old growth forest away, you burn it, you know, you girdle the trees, you cut them down, you just get rid of them. And it takes a while. And you use oxen power and young people. Everybody had a job because everybody could be a farmer, because everybody could afford a piece of forested land, and especially after the Revolution, when they paid the soldiers in land rather than money, because there wasn't any money. All right? And there was a burst of settlement that happened. And these are the characters that are doing that. And this is the scenario. Next slide. So this is important because I'm going to talk about this. This is zero population. The bottom is cut off, but this is 2000 right here, 2010, and this is 0, 1600, 1700, 1800, 1900. Today, okay? You got that? The bottom's chopped off? You can relate to that? So it's a linear scale of chronology. This is settlement, 1600. This is today. The population of New England is that dashed line. It's an exponential rise. You see that? So New England was never depopulated. They just left the uplands and went to the cities. But before that, everybody was kind of a farmer. Now, if you look at that thick gray band up here, this one right here, this one right here. Notice how there's everything, every New England state is about 90% forested at the time of settlement. Certainly this area. Okay? Anything that isn't an outcrop or a swamp or a dune or a marsh or a lake is forested. You see? The land is everywhere forested. Very, very slow until about this time right here. And then a rapid, this is Massachusetts, very, very slow settlement, rapid deforestation, down to about 30%. And then a rapid return of the forest. Next slide. Good. I don't have the chronology on the bottom, but I got 2 markers here for you. This is the American Revolution, right there. And this is the first rocket by Robert Goddard in Auburn, Massachusetts. America entered the space age in 1926, okay? When the first rocket was launched. And this is the America became America when it wins the revolution, right on this chronology. And so look at this descent, this rapid clearing after that. This is the post-war baby boom, expansion and taking over of New England. Most of the walls are in this vicinity and they're not colonial. In fact, the center of them are closer to the space age than colonial. You see? The center of them, the center of massive stone walls is in the sort of it's in the New Republic. You know, from about the turn of the 19th century, maybe we signed the Constitution, we're getting a lot of talk about that, you know, 1787, 1783, 1787, George Washington, blah, blah, blah. You know, it's all 1780s and 90s, right? But from then on, we are a new republic, proud of ourselves, clearing our land, growing our population, and building our stone walls. The Erie Canal in 1825 began to take it away. All right, that's right about in here. But there was so much momentum, we kept deforesting New England. Next slide. Millions of stone walls were built after the beginning of the American Revolution between 1775 and 1825. I'm just rounding it off to a 50-year period. Several important changes in rural society were responsible for what your local writer, Susan Alport, refers to as a frenzy of stone wall building. First, the rapid pace of wall construction coincided with a time when children of the post-war baby boom had grown old enough and strong enough to pick up stones. Surplus labor, by the way, I raised 3 15-year-old males in a house, and it was not easy. And if I were raising them in a house the size of my garage, all right, they would have been out picking stone. They would not have been in the house bugging me. Surplus labor was also available during one of several post-war recessions. Freed slaves, landless farmers, debtors, groups of tame Indians, disabled war veterans, and generally unemployed were put to work building stone walls. Second, the generally optimistic landowning farmers were self-reliant American citizens, no longer colonial subjects, with the confidence to build a great nation, if necessary, one stone wall at a time. This epoch broadly coincided with the Federalist period, a time when farming and animal husbandry became more scientific. Next slide. Oh, that's just, this was all lovely forest and soft soil until they cleared it. In Hillstead, that's a 1900s photograph. They cleared the land and look what happened. All that frost heaved to the surface. It wasn't there until they cleared the forest. Next slide. We know what happens under pastures. I drove by probably 10 equestrian farms on my way down here from Interstate 84. And the corner near the salt lick or the water tank or the barn is where you see what I see here on the right. Next slide. This is the physics. I'm going to skip it. Next slide. I'm out of time. 141. I'm going to finish here. Yeah, find the book. I can just quiet it down, right? I only have a few of them. Tens of thousands of stone walls were built during this period, blah, 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 blah. A visible man, blah, 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 blah. Using the average of these estimates for the rate of wall construction, and the estimated length of New England stone walls from the 1871 fencing census, 240,000 miles, equals 819 million feet, and 40 million man-days of effort would have been required to build them. 40 million man days worth of effort. Read 15-year-old boy days worth of effort. All right.
How many miles again?
240,000 miles. That's 10 times around the planet. Okay? And that's the distance to the moon. That's how many walls we got. That guy's got a check shirt on there. You can kind of imagine, you know, if every edge of every check was stretched out, it would go from here all the way to Interstate 84. You know, there's a lot of walls on that checkerboard. So, that's an awesome amount of manual labor by modern standards, but it's trivial compared to the much larger effort of getting stones to the edge of the fields in the first place. The job usually done during off hours, load by load from the previous generation. And then I go blah, 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 blah. I even once calculated that a single college football team, I did a year-long sabbatical in Dartmouth and I got to know the football coach, and I obsessed on a clinical book of nursing about the metabolic output of like football players, like how many milkshakes and french fries do you eat in a year for a season. So I converted the entire metabolic output of a college football team, an Ivy League football team, into a unit, and I called it an Ivy foot unit. Okay? And I once calculated that a single college football team could wall in 20 farms per year. So instead of just banging heads, you know, if they were put to work building walls, they could do 20 farms in a year. If we're 50 years old, right, that's 50, we've been watching it for 50 years, right, that's 50 times 20, that would be 100 farms, you know? It's crazy when you think about how much metabolic effort goes into football compared to building walls. And it turns out that, I think the average farmer spent 20 times as much effort chopping wood to stay warm as moving stone. We see the stone because it's still there. But most of the work, the hard manual labor, is invisible, as is virtually the entire labor done by women who are raising 4.6 children, right? And taking care of almost all of the stuff that they did, but it's invisible because it's mostly organic. It's gone. Next slide. I better get going. Yeah, I love this one. This is just shoreline. You got walls around here that look like that. Next slide. It's about the rock, not about the people who built it. One of these is Petersham, Massachusetts. It's a pattern of stone walls from the 1930 census. And one of them is got no human activity whatsoever. It's just Arctic polygons, you know, from frost heaving and fracture. But one is a pattern of stone walls, and one is Arctic polygons. Next slide. All right, so here we go. Now I'm getting to the thesis. It's chopped off. I don't know why, but on the left, that's radial disposal of granular refuse. Do you understand what I mean by that?
Yes.
They don't care about the thing. They're just bringing the sand up and dropping it. And there's a quote in this book that says that an ant doesn't care about its hill any more than a volcano cares about its cinders. You know, it's about material behavior and rheology and particle flow and all that. You get a lovely parabolic slope on a volcano. The volcano doesn't want it to look nice. It just happens because of the nature of the materials. Now, some ants, of course, can use their hills and they serve functions, but mostly they're just getting rid of it. But it's a radial pattern. The ant comes up like Sisyphus with a big sand grain and drops it, and it rolls whichever direction it rolls. And if you keep doing that, you get a bigger and bigger cone, not a different shape. On the center, that's a mud crack on a pond, right? You know, the pond dries up, you got a gooey silt, clay, and it just keeps shrinking, and eventually it just fractures. Lava fractures, too. So that's getting rid of strain. And then on the right, what are we doing? There's a polygonal pattern in stone walls, but it's an outward pushing, get rid of stone force. I'm being theoretical here. I'm not saying people didn't build walls. Let's move on. Get the idea? Next slide. I'm going to pick it up now. Get the idea? Next slide. Dead battery on a stone wall. I said, what the hell is the dead battery doing on a stone wall? And I said, oh, I know. Next slide. So I did a thought experiment and I built a wall out of dead batteries and I put a stone on it. And I said, that's it. They're there for the same reason. The height of a fence, your equestrian fences are not knee-high. Right? So most walls are knee-high, or were, when they're not being architectural. And again, I'm referring to the rural farm walls, not the fancy ones that I drive by.
And that's a 3-board equestrian fence, or a 4-board fence on the right. That's standard. Most New England towns stipulated that fences had to be, 4.5 to 5.5 feet high. And hardly any stone walls reached that height. Next slide. That's because they were basically holding stone. The Sierra foothills has the same look and pattern because you combine the ingredients. If you have granite and glaciation and animal husbandry, you get the same thing no matter whether you're in New England or the Sierras. There's an ecological factor. And then the cultural piece is on top of it. But what I like about it is it embeds human beings into the nature, that they're part of it, even in the historic period. Next slide. Land abandoned. I'll just skip it. We're out of time. But you get the idea. You know the story. People leave. They didn't leave because they wore out the soils. That's a myth. We love to think about the Eastern cowboy, the tough, tenacious, hero. Everybody likes, superheroes, but not me actually. Almost everybody likes superheroes. And we made a hero out of a tenacious farmer. They were just being, they were doing what we're doing, working based on incentives. Next slide. Rural revival. New England was under canopy forest until there were national policies to go back and please reoccupy New England. There's a colonial revival movement. It's all in the book, I got so interested in this. The story of this book is the story of me having 2 problems and then coming out the other end. One is I had a year-long sabbatical with an autistic kid, so we moved our entire furniture up to Hanover. And the pick was motivated by wanting to have a red house in a college town with a decent school in a park next, across the street. So it was, I could fool my son, into thinking we were living in the same place. Because that's what we had. And gosh, the guy that my sponsor just bailed and went to Washington, D.C. And I didn't know a soul at the university. And then the second one was that the book I was working on for the Geologic Society of America, the authors didn't come through. It's like an edited volume where nobody turns in what they promised to turn in. And so I bagged that and I just read for 6 months. And that's where this book came from. Next slide. That's an impressionist painting. Next one. That's just an old farm photo. I'm now not doing my reading anymore. Next one. Back to nature. The environmental movement, so-called, we're aware of it, beginning in the 50s, really accelerating in the 60s. It comes out of conservation, it comes out of Rachel Carson, it comes out of, a lot of stuff in the early 70s. And part of that is historic conservation, really giving emphasis to it. Next slide. And that's a natural sorted stone polygon in the Arctic. There's an outward pushing force, right, that segregates stone from the fine-grained materials. We tend to obsess on the stone walls, but the farmers were thinking about their fields. You see? Because we can't see the fields anymore. But we really think about them.
Is that a blue rake, like just for scale?
It's a long pole, yes, it's a survey pole. Yeah, they're not as big as our stone walls, but it's the same basic phenomenon. Next slide. So I'm going to do 2 readings and then quit because I'm already out of time. I told you if I did, what is it, balanced rock, I'd run out of time. 227. Like old ledges, we know what a ledge is, it's an outcrop. Abandoned stone walls can anchor our shifting lives to something rock solid, something natural. But unlike ledges, there's a human component in every stone wall. When I place my hand on one of the sun-warmed stones of my wall, and I'd like to ask you to invite yourself to do the same on your stone wall, it's easy for me to conjure up the image of the farmer who placed the stone there. His trousers muddy from the knees down, his shoulders locked for strength, his arms toughened by 1,000 liftings, and his bruised hands gripping the skull-sized cobble. By touching it, I can bridge the separation between my ruburban present and his rural past, at least for the moment. And then the last one is Emily Dickinson got the whole, master of abstraction, got the whole book in one phrase.
this book. So I'm going to read it. It's basically my summary of the history, and then I got a closing slide. Knowing that human antiquity is part of something as old as the earth reminds us of the dimensions of time. Stone walls hold time like a set of Russian dolls. The smallest doll, the one furthest inside, contains the oldest things in the universe, the elements. For example, oxygen and silicon. You know, they're elements. They're billions of years old. Outward dolls in succession are the minerals composed of the elements. Quartz is made of silicon and oxygen. It's a mineral. See? So outward dolls in succession are the minerals composed of the elements, the stones composed of the minerals, the wall composed of the stones, and the modern weathered surface, which is a blend of everything. All of this time is contained in every stone, quote, whose coat of elemental brown a passing universe put on, unquote, as Emily Dickinson wrote. A stone pulled from an authentic New England wall speaks all at once of ancient seas, glacial mud, and the tip of a side being broken during spring mowing a century ago. Next. Next. 12 chapters. Let's move on. I got a quickie. Next. This is me asking a crowd like this, a third grade classroom. How many of you have a stone wall in your classroom or nearby? I'm done with my talk. This is my coda. Okay? So, and you know what? The next slide shows the scene in front of me. If you care about stone walls, the smartest thing you can do is bring a kid to one. And they know how cool they are. I had 4 kids in town. I did experiments. You know, I'm like the dad that goes for second grade. So I'm there, and I say, kids, okay, go explore nature. They all go to the pond because they're programmed. But if you say, okay, kids, go explore, they go to the stone wall because it's more interesting. Okay?
Especially winter.
And they're programmed. But if you let them know there's cool stuff in stone walls, they just love it. And I've done a bunch of school programs. I'm just going to show you some of the paintings by Gustav Moore in the books Stonewall Secrets, and then just leave it at that. So let's just look at some of the paintings. There's a story to every one, the glacial stone. Next one. Oh, the National Science Foundation funding a curriculum project. This is the letter from the Mason saying, I want to buy your stone walls. That's it. Thanks. Yeah, but we gotta let people go.
Yeah, anybody wants to go?
We have 2 talks in one here. Yeah, question.
Should our balanced rock be called a balanced stone?
I would call it balanced boulder. Okay? Plymouth Rock, right? You know, it's sitting in its prison in Plymouth, you know, behind bars. Yeah. They call that a rock because it's big relative to the sand. You see? That's why they call it a rock, because it's big. And so a big one, but if it's big and rounded, call it a boulder. Call it a boulder. It is a boulder. Because a slab of rock, just like a jagged, flat slab, that's not a boulder, because doesn't have the corner milled off of it. But it's a slab. Unless you want to call it, balanced slab, you don't want that. I think balanced boulder is perfect, but you're not going to get rid of that. You're not going to get rid of the original name.
Yeah, things don't change around here very
No, they won't change.
Just to segue from that question,
Like trying to get a cell tower.
Oh yeah, let's put on top of it a cell tower? Huh? No, I thought you were going to put a cell tower on top of it.
No, you're saying that things around here don't change much. It's like trying to get a cell tower.
Oh, I see. Yeah, yeah.
you referenced in your book boulders, and I think the other term is flat rock. And just about every slide of, like we're watching right now, the wall is made out of boulders. The last slide of your presentation was what I guess would call flat rock. And there was one in the middle that seemed to be man-cut rectangular pieces or whatever, but mostly boulders. And the 30, 40 stone walls I've seen have all been boulders, and walking the field boulders. Where does the flat rock come from? Is it-
Basically, if you get that book, Exploring Stone Walls, which is not in print, but it's online, it tells you the difference. Essentially, if you have massive rock that doesn't have a grain to it, like wood or meat, has a grain to it, then it breaks in equal chunks, equal size chunk. Granite is the perfect one. So the closer you are to granite, the more likely you are to break into a block, which then becomes milled into a ball. You see, so it's rounded. You call them boulders.
Naturally milled.
Naturally, okay? But if you have layered metamorphic rock, where it's banded, or when it's got a grain to it, and the glacier picks it up and crushes it, it comes out as tablets and slabs. And tablets and slabs give you those layered flat walls that are very, very common. And there's really nice looking walls, but they're not nice looking because people cared more. It's just that the flat stones go together better. Because what if you're faced with, let's say we're in a library, look at this shelf here. What if all the books were on the floor? There'd be no room to walk, you see? But if we stack them up, there's room. And so think of a field that way, being a litter of stone. And the ones that pay off the most are the slabby ones, because they're the easiest to pick up and they cover most of the area. So there's a natural incentive to move slabby rock and make nice, good-looking walls out of them, because the good-looking wall happens somewhat accidentally, because the stone requires it. It's very hard to stack bricks without making it look good, you see? Because if you stack them, they're going to be stacked. But it's hard to take softballs and make a good stack out of them. Or watermelons or potatoes.
You referenced, I think there was a law or a mandate that walls had to be at least 3.5 to 5 feet tall.
Yeah.
What was the source of that? What was the governmental source of it?
I drove by the state troopers here. You didn't have them a long time ago. You had fence viewers. You had employees of the town whose job it was to make sure your fences were good. And they travel all around and they find you if your fences weren't good. Or if they didn't find you, if somebody's creatures got into your field, it would be your fault for not maintaining your fence.
So good related to height.
It's related to height and strength, but mostly height. And so in the town of Mansfield, Connecticut, where I live, generic, rural, suburban town, generic. The item most often showing up on the town meeting notes, tracing it all the way back, is fencing. And it went back 154 years in a row on the annual meeting where the discussion of fencing came up. And it was really important in that livestock tillage culture.
What was the purpose? To keep the cows in and not...
Yeah. Little boy blue, come blow your horn, the sheep's in the meadow, the cow's in the corn, you got to keep them separate. You have to keep the sheep and the hogs and the young bulls and the heifers and the cattle and the milch cows and the blah, blah, blah. And you want to rotate them around because they eat different things and use different things. You're just doing management of your property by parcels. It makes a lot of sense. So you need a lot of fences. But the thing is that if you go to a sheep fence today where the sheep are actually contained, there's probably an electric wire there, or barbed wire, or a tall fence. You go to a horse pasture, you're going to have, well, the standard height in all of those towns, our town was from 4 feet to 5.5 feet. And it's mandated by the town. And most walls are knee high.
And yet most of the slides you showed, I perceived those walls were not much more than 3 feet. Is
That's
that
right.
because of time?
That's right.
Elements?
Timothy Dwight, the master of Yale College, had it all right when he wrote 3,000 pages of travels in New England and New York. His vision was, the 19th century view, the 20th century view looking back, these are stone walls with an extra riser of wood on top to make them high enough. I mean, that's common. But what he said was, now that you really think about it, I think it's a wooden fence and the stone is growing upward from below to replace the wood. And I think he's closer to being right. Now, of course, that's a generality, just like everything's, when you try and reach a conclusion, it's a generality. But I really think that first of all, people love their stone walls, but most of the work was getting the stone to the edge of the field. Then the next thing what happens, it's a sprawling mass of, along an old fence line. The first fence lines are blazes, and wooden fences and stump fences, but we just don't ever see all of that stuff. There were always more wooden fences in New Salem than there were stone fences. Always. All right? In all of New England, there wasn't a single state that had, oh, Rhode Island did, but it's so tiny it doesn't count. Every state except that Narragansett Bay, all right, has more wooden fencing on the list than stone fencing on the list. And we just don't see it. Yeah,
I have a contemporary question.
sure.
So of the current day walls that are so in fashion, especially most affluent
Yes,
mega
yes.
houses, has a beautiful wall. Are those stones mostly mined, or is
Okay.
it deforestation, or are they stolen?
Stolen.
There's a lot going on. The saddest story I ever had was a woman in an audience. She came up and she wanted to share a story, and to honor her, I'm sharing it with you. She and her husband built a beautiful wall on the edge of their property, and outside of a kitchen window, and it looked really nice. It was just fronting the road. People in here have done that. It's kind of standard, And then he dies, and she is remembering him by the stone wall, all right? Because she remembers, oh, we built that together. How cool that is. It's nice, But what happened is people started stealing that wall, and because it's easy. All you need is a spotter up there with a flashlight and a spotter behind. I hope there's no spies in here, right? And a pickup truck in the middle.
Right.
And if the front one sees somebody coming, they flash the light, and the guy gets in his truck and is driving by the time the next one comes. And vice versa on the other direction. And you fill your truck with stone and drive off. So what she did was she said that she covered her wall, her project with her husband, she covered it with old rugs.
Old rugs?
Old rugs.
So they could still lift up the rugs and steal
Well,
the
they
stones?
could, but they're easy picking. It's harder to do that, so they didn't. And she said, I'd rather know that it's there than look at it. And that's the line I wanted to share with you. It's happy and sad at the same time. She's going to preserve her wall that she built, and it got pretty bad. It's getting better. It's getting better. No, so to answer your question, I don't like Machu Picchu walls, in Westchester, or in Guilford or Greenwich or wherever you've got, lots of money that you're hiring people to put the walls together with. I'm okay with hiring people to put your walls together, but where did that stone come from? If it's clean and cut, it's probably quarried, right? If it's dirty but not lichen covered, it's probably grubbed out of the field, which is another problem. It used to be, there were a lot of walls around here that I would drive by and I'd see them, they still have the lichens clinging on them, upside down. They were strip mined, I guess we're storytelling creatures. I received a letter once, shortly after I published Stone by Stone. It was from we have sons and daughters. They grow up in New England, they leave for where? Texas, California, the drill, Denver, this is happening, right? So she writes me from San Diego and she says, "Dear Dr. Thorson, thank you so much, for publishing your book Stone by Stone. It helped remind me of the walls back in New England." She said, "But I felt so bad, I just wanted to get a New England wall. So I went down to the garden center and bought some stone." And you know where that comes from. It's taken of old fields. They're archaeology. They're busy being archaeology. They're busy telling us our place in the universe. We shouldn't just strip mine them because they're there. Even though in the 30s, that would have been a great thing to do to make better roads.
There's no laws.
There are laws, but I think there are laws, but the fines are trivial. But it is working. Towns like New Salem, one at a time, are developing ordinances. One at a time, and it's a nonpartisan issue. It's a nonpartisan issue. I love it. I'm a political independent. I have been my whole life. I don't think well, that's a long story. But I'm an independent, and I love, this is a nonpartisan issue, because, okay, a Republican wants to pick their own leaders. That's what it means. The new republic, I use that word. And a Democrat thinks your vote counts and somebody else's vote counts. I'm both at once. Now I'm off this topic. Maybe you ought to get the film off. At any rate, so it's a totally nonpartisan issue. And I love it for that reason. Yeah, question?
Just an observation to help you get off the topic.
Thank you.
In Central America, they're using that technology that you described. LIDAR, did you call it?
LIDAR, yeah.
to identify the Mayan ruins.
Absolutely.
And it's incredible.
It's incredible.
What they're finding, only 5% of the ruins are being excavated, but
Yeah.
they're just vast. And even ruins that predate the Mayans, the oldest civilizations of the Americas, are now being used, that technology is being used in places like,
Everywhere.
I think Peru and Ecuador and places like that.
Everywhere.
It's
It's
mind-blowing what they're finding with it.
LiDAR is for landscape style scientists, people, archaeologists. You know what a microscope is to a cell biologist. I mean, it's just incredible. We know they're there. I mean, I've walked through enough woodlands to say, oh, I wish I had a good map of this. You know, and then finally LiDAR makes you to map it and see it in 1 meter detail. 1 meter. That's the scale now. Yeah.
Again, getting back to local, the stone walls that we see on our property now, are they meant to demark a certain acre? Do they have any reason for where they're located?
Yeah. There are reasons. The question is, do we have any reason to why they're located the way they are? Yes, it's a polygonal pattern that is dividing fences and fields, but the size of the pattern is largely about managing stone